Okay, hi and welcome to some video notes on 11.1, which we're going to call operations with radicals. This differs from the last couple of videos that we've seen where we've been dealing with one radical term and how to simplify a single radical term. Now we're going to talk about radical expressions with more than one term, meaning that we're going to have multiple radical terms, which introduces the concept of addition and subtraction with radicals. And how do we deal with that? So, first things first, let's talk about what like radicals are so that we know how to deal with this, right? Like radicals then have the exact same radicand or number, oops, let's see if we get that to go the right way. The exact same number underneath the radical. If they're the same, exactly the same, both numbers and variables, then we can add or subtract them together. If they're unlike or not like terms, or not like radical terms, then the radicands will be different, meaning that we can't. So if we were to add those radical of 4 plus the radical of 4 together, or the square root of 4 plus the square root of 4, we're going to get 2 square roots of 4. We'll talk about how that works in a second, but that's the general idea. We're going to take the coefficients of these, right, and then the coefficients add, where the radical stays the same. Operates very similarly to how we treat variables or combining like variables. You would treat it the same way. I know that there's a number, that's fine. And I know that the radical of 4 could come outside of the radical. That's not the point for that example. The point is to show that radicals or radicands that are the same can be added together and the coefficient changes or adds or subtracts up or down. Okay, so let's do some examples with this. Looking at this first one here, keeping that in mind, I'm going to elaborate on it and show you all the steps that go into it. So I'm looking at this now and I'm going to ask myself, is it like radicals here? Are these 2's, these radicands, are they the same? And of course they are. So what's going to happen? I'm actually going to add. I'm probably going to put a 1 here just to remind you the coefficient of that first radical term is a 1. So I'm going to take, and it's because they're the same radical, I'm going to take their coefficients and I'm going to add them together in front, and then I'm going to combine the radicals or the radicand under one term. That's what that looks like. Do we do that very often? Not really past this section. We do this just to kind of remind ourselves what operation's taking place. Of course, if we add 1 and 3, we're going to get 4, or the radical of 4 times the radical of 2. Again, the radical doesn't change. It combines under one like term, and then we add or subtract the coefficients. That's the kind of the operation that we're working with. So let's see that with subtraction now. Under subtraction, same thing, but you're like, wait, Mr. Hallam, you're doing ones with like radicands or like radicals expressed terms. And you'll see that square root of 3 and square root of 12 are not. So you're like, well, we can't go any farther. However, if you're clever, you would have noticed that 12 can be simplified. So maybe this involves some simplification first. Well, let's drop down our 7 square roots of 3 because we can't do anything with the 3. That is a perfect square term or a prime number. So we're going to subtract that then, but we can simplify the square root of 12. Right, and that's going to be 4 times 3. Well, let's just do a little side note over here. That's going to be 4 times 3. And 4 is a perfect squared term for 2 squared. So we end up with square root or 7 times the square root of 3 minus the square root of 2 squared times 3. The reason that we do that is because square roots and squares are inverses, and now that 2 can come outside. And if you're super clever, you'll also notice what that leaves behind under the radical. So we get 7 times the square root of 3 minus 2, because that comes out front, gets multiplied to the radical, times the square root of 3. Now we have like radicals. Those being like radicals, we're going to look at the coefficients, and we're going to subtract them and combine the like radicals under one radical. And now we're going to go ahead and finish this off. Oh, let's put my equal sign. And then we're going to say that that's going to be 5 square root of 3. So, again, elaborating here just to show you what's happening, that we're adding or subtracting the coefficients and that the radicals are being combined under one unit. All right, so let's move on to another operation that involves multiple radical terms. In this one, we've got a non-radical term and a radical term that's being multiplied by a radical term of the square root of 5. This is quite literally the distributive property. So we're going to employ the distributive property, meaning that we're going to multiply the square root of 5 to both terms inside of the parentheses, and we're going to use all of our simplification tools, right, that we know about radical expressions or terms, and clean it up afterwards. So this works just like you've done the distributive property before, exactly the same. So we're going to get, and I'm going to write this all out, square root of 5 times 2. That would be my first arrow. And then I'm going to put my addition sign down. That's going to drop down. And then the square root of 5 times the square root of 10. Recall that this is not, well, we'll do that in a second. This 2 is not underneath, so I'm going to rearrange it because we like our numbers that aren't radicals to be in front of the radical, so they're not confused to be underneath, right? So I get 2 square roots of 5 in the front, drop my plus down, and now remember, when we have 2 radicals that are multiplied, we're not dealing with addition and subtraction now, that are multiplied, they can be combined under 1. So we really get this, right? Square root of 5 times 10. Same thing. So let's drop down our 2 square roots of 5. Plus, let's start cleaning this up. I noticed that 10 happens to have a couple terms inside of it, one of which is going to be useful to us. So I'm going to break it up into 5 times 2, but there's another 5 under there from the first 5. So I've got 2 5s, which is going to let me clean them out, right? That's a perfect squared term. So 2 square roots of 5 drops down again, and we get the square root of 5 squared times 2. Now we can remove our radicals, right, for that part of it. So 5 is going to come outside of the radical. And we're going to be left with 2 square roots of 5 plus 5 square roots of 2. There's lots of 2's and 5's in here, but you have to ask yourself one important question. Are these values right here under the radical, the radicands, are they the same? No, they're not. So they're not like radicals. So we cannot add or subtract them in any other fashion. So we're going to leave it there. All right. So in this video, you've seen and had some experience with how to deal with multiple radical terms under addition, subtraction, and multiplication. All right, thanks for watching. There will be an example video where I'll do the other ones, so make sure you look for it and watch it, and we'll see you in class.